Hello, good morning, everyone. Saying morning because it's morning over here in Ohio. My name's Terrence. I'm going to be giving my presentation on the water quality and geomorphology of the Kaskaskia River watershed to meet the requirement for this senior or the synthesis project for um, the watershed science seminar. So let's go ahead and dive right in. So just a little bit of background on the river and watershed. As of 2018, the rivers and streams located within the upper and lower Kaskaskia River watershed, they were listed as high priority under the 303D EPA listing for impaired waters. And we're going to talk a little bit about why that is and what happened that led to those conditions. So looking at the Kaskaskia River, it is the second largest river system in Illinois. The river is 325 miles long, and it drains into an area of almost just about 6,000 meters squared within the central and southern portion of Illinois. It's a very important natural feature. It's located within 22 counties in the state of Illinois, which is equivalent size-wise approximately to 10.2% of the entire state. So a significant area with a lot of important, agricultural benefits, which we'll talk about. There's a lot of agriculture within that region. So looking at the kind of just the hydrologic categorization of where Kaskaskia sits in that cataloging process there. So the Kaskaskia River resides in the upper Mississippi region, which has an HUC of 7 and encompasses the states of Minnesota, Iowa, Wisconsin, Illinois, parts of Missouri, and Indiana. Illinois is actually considered a subregion, and its HUC is 0.713. And the Kaskaskia River watershed, which is what we're looking at, is an accounting unit as part of the Illinois subregion, and its HUC is 0.71402. Just looking at the land use, land cover, and how land use affects water quality in the Kaskaskia River watershed. The Kaskaskia River watershed is an important agricultural area in the southwestern portion of Illinois. 82% of the land use in the Kaskaskia River watershed is agricultural cropland. The major non-point source pollutant is agricultural runoff, and it's believed to be the leading impairment of rivers and streams in the USA. So ultimately, when you're looking at the area that has 82% cropland, it would make sense that agricultural runoff is probably going to be your major non-point source pollutant within the region. So. And there are, of course, increasing concerns with urban development, storm flow, storm water runoff, and things of that nature as well too. But agricultural production in the region seems to be what a lot of studies are focused on and trying to alleviate or mitigate the effects of non-point source pollution. So. Past studies on watersheds that are predominantly agricultural or cropland or oriented cropland have significantly higher total nitrogen concentrations. One study by Miller, they studied 43 catchments, and they were all selected from the lower Kaskaskia River watershed, where they took grab samples and analyzed for nutrients such as nitrogen, phosphorus, bacteria, and total suspended solids. And in the same study, forest and urban land cover were included in 6 of the 10 regression models that were produced. And some of the regression models that were for base flow conditions suggested that forest land cover had a significant impact on base flow water quality. Um, and then urban land cover had a greater impact on storm flow conditions, which makes sense. When you're dealing with urban land cover, you're dealing with more impervious surfaces, and of course that would increase your runoff coefficient there. And just going on a little bit more on the land use and land cover and water quality. The watersheds, and this is the same study as well too, the watersheds or catchments were divided into LULC categories, of which were agriculture, village, and urban watersheds. And the results of the study revealed that during base flow conditions, agricultural watersheds had significantly higher total suspended solid concentrations, and then urban watersheds had significantly higher organophosphate uh, concentrations. All watersheds in the study contained orthophosphate concentrations higher than the statewide 95th percentile for Illinois streams. And then E. coli during storm conditions exceeded the national U.S. EPA criteria in this region during the study. So basically, what happens is, when a water body or when a state, EPA or state agency reports that a water body is impaired, and it gets listed under the 303D listing process with the US EPA, then they're required to create these TMDLs, which are total maximum daily loads. And basically, they're mathematical tools used to determine the maximum amount of pollutant allowed to enter the water body. Criteria also developed according to designated uses as well too. So TMDL criteria are linked to the use of the water body. And then LRSs, those are load reduction standards, and then they're basically used when there are no numerical water quality standards for certain pollutants. So if a pollutant doesn't have any water quality standards, it means there's probably still undergoing some kind of study or review, maybe some research being conducted, but there's not enough historical information to base any kind of TMDL reasonable TMDL standard or guideline or criteria. So load reduction is the method to basically you want to try to limit that contaminant or pollutant as much as possible because there's still a lot of uncertainties around it. And then it's also based on a ranking or priority system, ranks it from high to low, and that's also dependent on use as well too. So, just for example, public and food processing water supplies, that's ranked as high priority. Primary contact recreation, so swimming, that's ranked as medium priority, and then all other uses are prioritized by number of impairments. And then the TMDL development in the Kaskaskia River watershed, the state of Illinois sent in final reports, which were approved by the EPA between 2018 and 2019 for the upper and lower Kaskaskia River watershed. So looking into the upper Kaskaskia River watershed, and I just included that graphic there to show, what the general use water quality standard guidelines are. So for fecal coliform there, it shows you, the different guidelines, and yeah. Looking in the upper Kaskaskia River watershed, primary pollutants of concern was fecal coliform bacteria, most likely due to the health risks associated with skin contact and human consumption. So fecal coliform bacteria is a good indicator, water quality factor or a guideline. It helps determine the potential for other disease causing bacteria within that water body. So high concentrations of fecal coliform bacteria are probably also associated or is a strong indication that there may be other disease-causing bacteria within that water body as well too. And then just some guidelines on U.S. EPA fecal coliform, based on the designated use, body contact, swimming again, not to exceed 200 colony forming units per 100 milliliters, fishing, boating, domestic, and then drinking water supply. You definitely would want that to be the lowest of 1 colony unit there, so you don't want to drink a lot of gut bacteria or bacteria that's not necessarily could lead to a disease. So let's see here. And then primary sources of the fecal coliform identified in that impaired segment of the Kaskaskia River came from livestock with access to riparian areas, livestock feeding operations, municipal point source discharging, on-site water treatment systems, urban stormwater, and agricultural runoff. And then looking at the lower Kaskaskia River watershed, there's 2 uses here in this one, in this graphic here: general use and public food processing water supply. And they look at dissolved oxygen, iron, and they have their own water quality standards based off, again, the use of that water body. So one thing I wanted to note was that iron actually itself is in low concentrations, I should say, low risk to human health. However, there are aesthetic concerns, which seems to be more of the concern with iron, is that the aesthetic concerns is the color of water, when the iron oxidizes, and then also too the presence of bacteria that incorporates iron within their metabolic processes. So, iron reducing bacteria, those are kind of the concerns when iron above their recommended limits or maximum contaminant level can lead to poor aesthetics and then iron reducing bacteria. And it doesn't take that much, from my understanding, 0.27 or 0.3 milligrams per liter of concentration of iron in the water is all you need for that aesthetic quality to go down. Start getting that brownish reddish color to start forming in the water. So and then kind of looking at the lower Kaskaskia River watershed area there, primary pollutants of concern was iron, and that's what we were talking about just now. Same thing, it talks about, not to exceed a certain maximum contaminant level, low risk to human health as far as, low concentrations are concerned, and then aesthetic concerns are the main concern for iron. So. And then the primary sources of iron and dissolved oxygen impairments identified in the impaired segments of the Kaskaskia River, according to the report, they most likely came from channelization, dredging, industrial facilities that are discharging into impaired segments. So your point source polluters, right? Which included active coal mining facilities, gas and exploration companies. And one thing that the study highlights, which is kind of interesting, is that these facilities had NPDES permits for iron concentrations that were higher than the general use water quality standard. So I found that kind of interesting. They even mentioned that poses concerns or is problematic for the project and long-term goals of reducing certain pollutants within the water body. So kind of a little bit political. And then what is fluvial geomorphology? So going into the fluvial geomorphology of the Kaskaskia River watershed. Of course, this is one of the topics in this course that we learned. And fluvial geomorphology is the study of the form and shape of the rivers and its streams. as they flow over the earth. This includes characteristics of river such as size, cross-sectional shape, longitudinal profile, landform pattern. And there are various natural processes that affect it: hydrology, sediment transport, erosion, energy distribution, and stream power. So, one of the things we know about fluvial geomorphology is that the geomorphological characters, such as form and shape, are very much influenced by the distribution of energy. So, what is stream power? Well, Stahl and Yang, in their study, define stream power as the time rate of potential energy expenditure per unit weight of water of natural stream. Um, they look at the distribution and variation of unit stream power and how that affects form and shape of the rivers and streams. And then stream power can be regulated by the stream via meandering, pools, riffles, longitudinal stream bed profile, and things of this nature. So, and then looking at the study, so the study that they did was on the hydraulic geometry and low stream flow regimen. They studied the Kaskaskia River Basin, and ultimately what they demonstrated was how the distribution of stream power can have an impact on fluvial geomorphology. So the study analyzed a 53-mile reach of the Kaskaskia River, looking at the structure of pools and riffles and the flow conditions that basically form them. The study indicated that low flow conditions along that 53-mile reach ultimately led to the creation of localized pools, riffles, and shape of the stream within the study location. Based off of their analysis and calculations, that's the conclusion that they came to in their study. And then processes affecting fluvial geomorphology in the Kaskaskia River watershed. A lot of the processes can be anthropogenic in origin. So there's obviously a lot of anthropogenic factors that have influenced fluvial geomorphology of the Kaskaskia River watershed. Some of these processes include channelization, again, dredging, reservoir development, which it is important. Reservoir development is important for supplying water to the general public. However, there are some negative impacts to these man-made or man-induced anthropogenic processes, which are deterioration to the riparian zone vegetation, which, of course, we know plays a key role in the stream bank stability. Channelization, dredging, harming the riparian zone vegetation can lead to erosion, sedimentation in certain areas, and can even lead to inundation and habitat loss. So, that's something that is should be highlighted, right? When we do these projects to make sure that there is some rehabilitation process going along, at the same time as these projects to try to alleviate the negative impacts. So processes, again, looking at the Kaskaskia River watershed, we probably would have to say that the development of artificial lakes and reservoirs are probably the major anthropogenic factor. They do have 10 artificial lakes throughout the Kaskaskia River area. And, in this Illinois Department of Natural Resources kind of assessment, what they ultimately come to the conclusion of, or what they basically say is that this kind of artificial lake development, reservoir development, increases the variability in the rates of erosion and sedimentation, and leads to can lead to ultimately lead to bank erosion. So negative impacts on riparian ecosystems can lead to habitat loss due to increased flooding. So these are some of the impacts of just some of the anthropogenic factors that affect fluvial geomorphology. And in that same Illinois Department of Natural Resources assessment, lake sedimentation surveys were conducted by the U.S. Army Corps of Engineers. They looked at lake sedimentation rates for 10 lakes in the Kaskaskia River Basin. And what they found in that assessment is that it's easier to, assess sedimentation within a lake because, in those artificial lakes, there's a dam and you have very slow moving water, so it's easier to measure sedimentation in the lakes versus a faster moving body of water where dispersion processes and just the sheer speed of the water kind of makes it difficult to accurately measure sedimentation. But within the lake, they can do pretty good studies because of it being blocked off by a dam. So, and then just ultimately what I concluded, when going into this and coming out of this study and looking at the literature was that well, as of 2019, it looks like the TMDLs have been created for the upper and lower Kaskaskia River watershed. They have been approved by the EPA. And then, I just I feel, in my opinion, efforts should be made to reduce the NPDES permits to mining and fossil fuel exploration companies that exceed the EPA's clean water standards. And again, this is my personal opinion, but if clean water standards or have criteria have already been set, the EPA's already set standards. It doesn't make sense to provide NPDES permits to coal mining and fossil fuel exploration companies that exceed those standards if the ultimate goal is to create TMDLs and load reduction standards to ultimately alleviate the negative impacts of the pollutants of concern. So definitely, would feel that would make sense to reduce those permits that are being given out to exceed clean water standards. So definitely a political battle, it seems. And then non-point source and point source pollution. Kind of goes back to the very beginning. Ultimately the literature kind of points to that non-point source and point source pollution had more of a contribution to the Kaskaskia watershed impaired water bodies versus anthropogenic alteration of the natural fluvial geomorphology. So there are definitely water quality issues associated with altering the natural fluvial geomorphology. Increased concentrations in certain pollutants and certain nutrients have been found in certain studies, but ultimately the biggest contributor to the impaired water bodies were non-point source and point source pollution. So this concludes the presentation, and thank you so much.